Okay, last time you did this whole matrix thing. Okay, let me get a summary, quick review. You have three equations. You have three variables. Um, you can set up all these linear equation into, we call this augmented matrix. Okay, this is called augmented matrix. So this stands for the x, the y, and z, and this will be the fourth column, okay, which is the right side of the equations. Okay, so what we did is we need to somehow getting the three number in the corner bottom left to be 0. It's 0, 0, 0. Okay. So we did some manipulations, getting this to be 0 because it's 1, 1. And this 1 and multiply 3 because it's 1, it's 3. To get it to be 0, we get 0 here. And then so this is called another name is so we call this augmented matrix, or the whole thing is called the row echelon. Oh wait, I believe row echelon should be this one. So if you get 1, 1, 1, 0, 0, 0, this 1, 1, 1, 0, 0 is called row echelon form. This is the form that you want to get as a result. Oh, the whole operations, it's called the uh, row elementary operations. Okay. So what we can do here is we can exchange the row 1 to row 2. We can flip uh, as much as you want. You can add, you can subtract, you can multiply and then subtract, you can multiply and add. Basically, most of algebra you can do. Okay. Let me give you the summary, okay, of the okay. So what we did is called the Gaussian eliminations. So the one who invent is the Gauss. He is also invent the uh, normal distributions, Gauss functions. If you want to look up the Wikipedia or the other sources, you can look up the Gauss. I think he invented this elimination method when he was uh, maybe around still small boy, maybe 10, maybe still a child. He invented this method. So I'm giving you the guideline. Okay? Start by obtain 1 in top left corner. and obtain zeros below that. Number 2, obtain leading one in next row. Then obtain zeros below that. Rearrange if you want, rearrange rows. Continue until you get the row echelon form. Okay, if you confused of the sentence, you don't understand if the sentence, let me draw some picture. This is for 3 variables linear equations. Okay. So the first thing is you need to make the top left 1, the below is 0. That's the first thing to do. Okay. So basically, there are no specific guideline like you can do anything, but this is to help you getting um, the goals, in which the goals is to find the solutions x, y, z. Okay, so you need to get 1, 0, 0. Okay, and then after we get this 1, 0, 0, we need to move on to the next step. And getting so the next step after the first one, 1, 0, 0, we need to get 1, 0, 0 and 1, 0 here. Okay. And I think up until here, if all this black rectangle is a specific numbers, then we can say that we are finished. We need to just divide this and become 1, and then that's it. It's the solution. Okay, so z is this number, and then this y is y plus how many z here. It's substitute z here, and you can compute y is equal with what number. Okay, and this also x is what number. Okay, I hope you understand the how to get the row echelon form. Okay? So let me draw the finished one. So this is the finished product. Okay. So this is the third step. So the last step, finish. Okay. That's for the Gaussian eliminations. Okay. So write the augmented matrix. Get the row echelon form. And then substitute. Okay. Okay, now let me get back to this equations. Let me make a new one so we can try how to uh, and let me make the augmented matrix first. Okay, can you try? Can you try to solve it using the finding the row echelon form from this augmented matrix? Let me make it bigger. Okay, so the elementary operations is, from my perspective, is very fast method to solve linear equations, finding solution. Imagine this is only three variables, like x, y, z, right? If you have 5, 6, 7, and maybe you want, maybe you say that, oh, we see 3 variables. Oh, I can do it, just eliminations, substitutions, etc. Right? What will happen if you have 5, 6, 7? This method is helping you in that way, as long as your computational is good enough. Okay, you can do it very fast, and you can imagine how the machine can works or operate based on this instruction. So if the machine have the instruction, okay, I need to get this 1, 1, 1, and 0, 0, 0. And they can manipulate all the possible things that can happen. Okay? And they need to find the fastest way to get 1, 1, 1, 0, 0, 0. And I think that's basically how the computer works. Why they can they can move faster, or they can think faster. So there are so many ways to get your solutions. Okay. If you want to know at least the guideline, just looking back at my review, our review. So we need to just making this one first. If we see 4, 8, negative 4, and 4, let's just divide by 4, right? So it's become 1, 2, negative 1, 1. Or you can see another number, but you see that the other number, the number have if you divide, maybe have a fractions, right? It's become a rational. So probably the best way is the first one is divide by 4 to get this one. And because this is 1, this is 2, because this one, the other, if you want to subtract or add this one, you can add by multiply or subtract by this one by multiply. So if this is 1 is 3, maybe I multiply this 3 and then minus 3 here. So I get this 0 and others. Okay. Mm-hmm. Yeah, you can write a fraction. Still fine. Okay, let me solve this. Um, this 3 and negative 2, they both need to be 0, right? Need to be 0. So let's compute them. So this is row 2 minus 3 row 1. Let me write in the black color. So 0, 2, negative 5 minus 5 plus 3 is negative 2. Negative 11, negative 3 is negative 14. And this will be R3 negative 2 R1. Oh, plus 0, 12, negative 2 is 10. Negative 17 plus 2 is negative 15. Okay. Now I need the 5 to be 0. So I need to multiply by 2 and the other multiply by 5 to get 0. So let me write. So 1, 2, negative 1, 1, 0, 2, negative 2. So this is 0. And I need to write down 2R3 minus 5R2. So 5 to 10 is 0. 20, 20 minus it's 30. And the last one, negative 30 minus negative 7. So it's 40, 40, right? And then we write down 1, 2, and divide by 30. So it's 4 over 3, right? Anyone got the same with me? Same? Okay. So let me write the whole. Let me divide by 2. Divide by 2 is 1, negative 1, negative 7. Yeah, it's not really a good number, but it's still doable. Z is 4 over 3. So y minus 4 over 3 is negative 7. So y is negative 7 plus 4 over 3. And x plus, yeah, and you can solve that. Okay, up until here, this is already correct. Okay, this is the row echelon form that we want. Okay. Okay. Besides the Gaussian eliminations, there are another method with the same name Gauss-Jordan. It's called Gauss-Jordan. The idea is we have 0, 0, 0, but we want to make the answer like z is already 4 over 3. So the idea is having the other 3 number here getting 0, the right top corner here. So because you see we already have this 0. So for example, if I want to subtract row 2 or add, because I have negative 1 here and plus 1, I can add row 2 and row 3 and becoming this 0, right? And I get exactly y is equal this number, right? And this also the same. It's -1. I can make this 1 minus plus this is 0, right? But I still have these 2. Oh, okay. I can still maybe add or subtract, and maybe the other will be multiplied by 2. Okay. It's called the Gauss-Jordan eliminations. I believe I think I wrote the wrong equation, but it's still doable. I hope this is not a fraction, but yeah, but it's still okay, still okay. Maybe I'm wrote the wrong equation. Okay, I will write in this area. We also have the Gauss-Jordan eliminations. So I will just draw a picture so you get the idea. So this is what you are doing before, right? Or let me draw until the row echelon. So instead of substitute back, we can make 0, 0, 0. So we can get our final product is having 0, 0, 0 in the left bottom and then 0, 0, 0 in the right top corner. Okay. This form is basically tell you that the x is exactly this number, the y is exactly this number, and the x is exactly this number. Okay. Anyway, the Gaussian or Gauss-Jordan both basically in a principle is the same. Okay, it's the same. You just need to continue your work on the previous method and getting 0, 0, 0 on the right top corner. And to avoid mistake in the row echelon, how to find the row echelon, usually when you're doing the elementary process, subtract, add, you need to avoid making a cycles. That's the thing that uh, happens frequently. For example, you already get 0, 0, right? And maybe in your next calculation, maybe you wrongly calculate the number, and then the 0 disappear and become a number. That's common. That's common. Okay, that's the one thing that you need to avoid. Okay, so you need to keep this 0. Okay? You need to keep this 0. If you like from the calculation, oh, you get a number here, then you need to step back and uh, unless you want to rewrite all the operations. Okay, so it's like when you're doing exam, you need to precisely know what to do. Okay, do not write anything that okay, maybe this will do, and then you write the whole paper, but you get 0 at nothing. It means that you need to focus on each step you take, okay? Which row or which column you want to take on. Like for example, it's already 0 here, so do not make this a whole number again. Okay, so keep this part 0. Okay, see what I mean? If you see this 0 and you want to make this 5 is 0, then the only row that you can do is this 2, right? If you think the first row, you will add 1, right? In it, maybe this will be, okay, oh, this 2, maybe I can minus this 2, and this will be 0. But the other, maybe not, okay? Or maybe this 5 with this 2, and maybe you will change the 0. Okay? But anyway, there's many ways you can do. Okay, but the guideline, I think, generally will be good for you, making this 1 0 0 the first time, and then the rest you can do and it as much as you want. Okay, okay, that's the Gaussian and Gauss-Jordan eliminations. And still, let me go back here. I will remind you that if you find there's number here, and you find this is 0 0 0 1. Okay, this means it's no solutions. Okay, so maybe you are doing the finding the row echelon and you get 0 0 0 and 1. You need to get 1 here, right? So if this happens, this means no solutions. Okay, and I think this is the perfect one. So you get something here, something something something, number, all numbers. So it means it's perfectly one solution. So one solution for z, one solution for y, one solution for x. Okay. And the other one is if you have 0 0 0 and 0, and you have all the number here. This is infinite infinitely many solutions. Okay. Uh, Let me continue a little bit to get a brief idea for the matrix and its algebra. Okay. So if I have matrix A is compound of this number, meaning you can have A1 1 until A, okay, and I have B, same thing. You can add A plus B if okay, if the column if row and column A is equal B, okay, then you can add A plus B. You can minus them. Um, you can multiply by a constant. Meaning the constant will be multiplied with all A inside the matrix, okay? And some property, You can A plus B is the same as B plus A in matrix. Okay. And if you want to add A plus B and then add plus C, it's also the same as A plus B plus C. Okay. And if you multiple with this several constants, like for instance, C is constant, D also constant, then it's actually multiplying both of the scalar. So if you multiply the scalar with the A plus B, it's the same as C A C B. Okay. So C is constant here, and this C is matrix. Okay, the big C. And how to compute if you are doing this all algebra in matrix. So let's say we have A1, A2, until AN. Okay, and you get like a row. Okay, and you get the, for example, okay, P1, P2 until Pn. Multiplication in matrix works row, multiply, and additions with the column. Okay, so this will be A1, B1 plus A2, B2 plus dot 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 AN, Pn. So if you have like maybe you have some row and column, okay, what you need to do is to make sure that the row and column on the other matrix is the same row and column. Okay. For example, if you have the A is 4, 4, or maybe 3, 3, you need to make sure that the B also 3. Okay. At least the row is 3, 1, 2, 3. Okay. For example, if you have like it's perfectly 3, 3, and the second one and the third one, okay, that you can do. But if this is making 4 or 5, you cannot multiply that matrix. Okay, I will review more tomorrow. Okay, so at least the introduction for the algebra for the matrix, at least that. Okay. So I think that's all for today, and tomorrow I will give you the quiz results.